Today we're talking about different quadrilaterals and what makes them unique. But before we talk about our quadrilaterals, we need to talk about new vocabulary words. Three words we're introducing today are line, parallel, and square corner. Now, a line is a straight piece with a start and end point. A parallel means two or more things are going the same direction, then they never touch. A square corner is a corner that is made up of a horizontal line and a vertical line. And it looks like the corner of a piece of paper or an index card or something like that. Here we have some examples. A line starts in one point, ends at another, and it's perfectly straight. These parallel lines are going the same direction, but they will never touch. If we try to put a ruler next to them, for example, you would see that the lines would continue indefinitely and they would never cross. We'll explore that a little bit on the next page. And here we see a square corner. The reason it's called a square corner is because it resembles a square. We represent these by drawing the other part of a square inside of it. These can be seen in several varieties. They can be seen in these horizontal and vertical lines. They can also be seen with these oblique lines, or lines that are at an angle. So, how can we tell if two lines are parallel? Well, we can tell two lines are parallel if they are going the same direction and never touch. These two lines will never cross. But if I changed how my straight edge looks by even just the littlest bit, eventually these two lines would cross. I'll go ahead and draw a second line to show that right now. So by changing my straight edge just a little bit, you can already see that it's wider on the left side, and it gets thinner and thinner on the right side until things will touch. So I'm going to go ahead and draw. Yep, come on. Go ahead and draw a line. And here we go. Here's an example of two lines that are not parallel. This bottom line traces up and up and up until it crosses the other first line at this point. So why does that matter? Well, certain shapes require us to draw parallel lines, and subshapes will use non-parallel lines. So let's take a look at several quadrilaterals. So I've already started off by drawing our most iconic quadrilateral. This is a rectangle. You might be thinking, but Mr. Muse, that's a square. A rectangle is described as this. A rectangle is a shape that has two sets of parallel lines. So these two lines are parallel, and these two lines are parallel. And they have square corners, which I will show now. That's a square corner. That's a square corner. That's a square corner. That's a square corner. Now, a square is a kind of rectangle because it has two sets of parallel lines, but it just so happens that for a square, all four lines are the same size. That's what makes a square unique. So I could draw another rectangle very quickly with two sets of parallel lines. And square corners. These corners are square because they resemble the edge of a square. And as we just saw, those lines will never touch. They are parallel. Okay. Now what about the other kinds of parallelograms? Well, we have other parallelograms such as trapezoids. Quadrilaterals. We have other quadrilaterals such as trapezoids, parallelograms, also known as rhombuses, and we can show them right now. Now, what is a trapezoid? A trapezoid is a particular quadrilateral that only has one set of parallel lines. That's what makes a trapezoid unique. So here's one parallel line set, here's a second parallel line set, and now for a trapezoid, we'll end up having at least one oblique line. Oblique meaning at an angle. Now trapezoids can have one side like that. So for this trapezoid that I'm drawing, for example, it's sort of like a rectangle, except for this one side here that intersects and it's not parallel. So let's take a look at a different kind of trapezoid. Trapezoids come in all shapes and colors. Well, of course they do, because we can use whatever color we want. But they come in all different forms. Also, I'm sorry if you hear noise in the background. Rallis is currently in here, and he is not being very considerate of class time. But that's okay. He's cute anyway. Other parallelograms, other trapezoids, I should say, have one set of parallel lines. And then they have two lines that are not parallel. So for example, goodness, this is there we go. So for example, this trapezoid has two angled lines that intersect with it at two different points. A trapezoid has only one set of parallel lines. The other lines are not parallel. I'm going to mark parallel lines really quickly with these yellow marks. When lines are parallel, we can show that. There we go. We can show that by using these straight lines to say, hey, these two lines, we know they're not going to ever touch. Okay, next, we're going to look at parallelograms. What if I told you there's a square that isn't a square? It sounds confusing? Well, a parallelogram works like this. Parallelograms don't have all horizontal and vertical lines. What a parallelogram has is two sets of parallel lines, and one set of these lines makes it so that it does not have square angles. So let's take a look at this. Whoa. Here I've drawn what is known as a parallelogram. It is also known as a rhombus. This one is known as a rhombus. A rhombus has four sides that are exactly the same length, just like a square, and it has two sets of parallel lines. These two lines will never touch, and these two lines will never touch. But what makes the rhombus different, what makes parallelograms different from rectangles and squares, is this, the angles. The angles are not square. If we compare this rhombus to this square, we can see that the square has these boxed edge angles, and this rhombus has angles that are bigger than that box edge and smaller than that box edge. We'll talk more about what we call these angles in a future lesson, but for now we're just learning that different shapes have different angles. So let's take a quick review also of a trapezoid. In this trapezoid, we have 4 angles that are not box angles, but this one has them as well. Well, a trapezoid is, again, one set of parallel lines, and then the others are whatever you want them to be. One set of parallel lines. Okay, so let's take one last look, and we're going to identify the shape's name and draw an example of each shape. Here, we're looking at rectangles and squares. A rectangle is a quadrilateral with 2 pairs of parallel lines, and the angles are square. A square is a special rectangle that has 4 equal sides. So to draw some examples of these, you'll see here that a rectangle is not necessarily every side is equal, whereas a square will end up as all sides are equal. Oh, let me try that one more time. There we go. And we can see from this example that these corners are squared. You can fit the corner of the square snugly into it. And you can see that this rectangle has one side that is much longer than the other. On this page, we're reviewing parallelograms. A parallelogram is a quadrilateral with 2 sets of parallel lines, like a rectangle. However, the angles are not square. A rhombus is a special parallelogram with 4 sides that are the same size. Now, let's take a look. We can see here that on this parallelogram, just like on a rectangle, one side can be longer than the other. So these top and bottom lines are parallel, but they're also much longer than these lines that are on the right and the left. On the rhombus, the lines are the same size, and just like the parallelogram, the sides, the angles are not square. If we took a rectangle or a square and we put it up to the angle, it doesn't fit perfectly in. You can see there's a gap there. And if we try doing that with one of these small angles too, you can see here that it spills out over that blue line. So that's how we know a parallelogram is from a square or a rectangle. The corners are not square. They don't match up. So now let's take a look at another shape. Trapezoids. A trapezoid is a quadrilateral with only 1 pair of parallel lines. Now, here is an example of a trapezoid. We can see here that one set of lines, the lines on the top and bottom, are parallel. They will never touch. But this straight line going down on the right side will cross with this line on the left that's going at an angle. Now, trapezoids can show up in many different shapes and orientations. You can have trapezoids that, I'm going to draw them less perfectly now. You can have trapezoids that have 2 parallel lines and then 2 pinching in lines like that. You can have trapezoids that have 2 parallel vertical lines, but 1 line pinching in. You can have trapezoids where you have 2 parallel lines that are going at an angle, and then the other 2 lines are crossing otherwise. Oh, that's a triangle. There we go. There's a parallelogram. A trapezoid. Boop, there you go. Examples filled in so you can see them. And so, we can tell a trapezoid apart from the other ones because it has 1 set of parallel lines The angles don't matter. We're not worried if the corners are square or not, because as we can see, trapezoids come in all kinds of things. These corners are not square, but this corner is square, that corner is square, that corner is square. You see, they come with all different kinds of angles and corners. So, how do we tell shapes apart? Well, our squares and rectangles have two sets of parallel lines that have square corners. Parallel lines will never touch. Our parallelograms have two sets of parallel lines, but their corners aren't square. And a rhombus is a special parallelogram that has all of its sides as the same size. And lastly, we have the trapezoid, a quadrilateral with only one pair of parallel lines. The other two will intersect, and that's the only thing that makes the trapezoid different. Alright, with that, time for us to get our practice in. We're going to practice today drawing examples of each shape and identifying how we know. Feel free to tune back in here if you need a refresher on how to tell the difference between quadrilaterals.